Alright, in this video we're going to go over solving systems algebraically. Alright, here's your vocab. Equivalent systems. When two systems have the same solutions. Alright, make sure you write that down, that's your vocab. Alright, the first way we're going to go over solving a system is by using substitution. Alright, by using substitution. So we're going to solve this system using substitution. Alright, so the first thing we need to do with substitution is we need to pick one of the equations and solve it for a variable. So we need to solve it for either x or y. Alright, now if we look at the second equation, y is already by itself. You know, there's no coefficient. Or it has the coefficient of 1, because remember there's always the understood 1. So it would be easiest to solve this second one for y, and then we'll plug it in for y in the first one, and then solve that way. So if we solve this for y, we're going to subtract 2x. So y equals 10 minus 2x. Now that we know what y equals, we're going to take what y equals and plug it in for y in the first equation. So we're going to have 3x plus 4 times 10 minus 2x equals 12. And now we're simply going to solve this. Distribute that through, we get 3x plus 40 minus 8x equals 12. See, this is negative 5x plus 40 equals 12. Minus 40 minus 40. Negative 5x equals negative 28. Divide both sides by negative 5, and you should get x equals 5.6. Okay? You get x equals 5.6. Now in this case, I don't mind the decimal. But if you can give me a fraction, give me a fraction. Now that we know what x is, we're going to plug this back in up here. Now, when we go to plug it into one of these two equations, pick the easiest equation to solve. And that would be the 2x plus y equals 10, because the numbers are smaller. Right? So pick the easier equation to solve, and then plug in your x value. 2 times 5.6 plus y equals 10. 2 times 5.6 is 11.2 plus y equals 10. Minus 11.2 minus 11.2. Y equals negative 1.2. So the solution to this equation would be 5.6 comma negative 1.2. That would be our solution. All right. So for substitution, what you do is you pick one of the equations, solve it for one of the variables. Okay, in this case we solved the second equation for y. Then you take your solved equation and plug it in for that variable in the other equation. Just like we did, we solved for y. We got 10x minus 2, so we plugged 10x minus 2 in for y of the top equation. And then we solved for x. Now, if you solve for x and you plug in for x, then you solve for y first. That's fine, doesn't matter. All right, but once you have one variable, you solve down for it. Then you pick your easiest equation out of your two originals, plug that variable in, and then solve for the next one. All right, that's all there is to substitution. All right, now let's look at elimination. Elimination. It implies, and you solve this how the name implies. You want to eliminate a variable. All right. You see here how that we have 4x and negative 4x. So if we were to add these together, that would cancel out. All right. This would give us 5y, and then this would give us 25. And then of course divide both sides by 5. So y equals 5. So now we have our y value. And you do the same thing. You plug it back into the one that you think is easier. I'm going to do the 4x plus 2y equals 9. So it's 4x plus 10 equals 9. 4x equals negative 1 divided by 4. X equals negative 1/4. All right. So our solution for this one would be negative 1/4, comma 5. All right, so elimination is just that. You want to eliminate one of your variables. All right, you want to eliminate one of your variables. Now, elimination goes one step further. All right, this is called solving an equivalent system. Okay, but it still involves elimination. All right, it still involves elimination. Let's look at 2x plus 7y equals 4, and 3x plus 5y equals negative 5. Now, this one wasn't as nice as the first one, where they gave us 4 and negative 4. Okay, so they'd easily cross out and cancel out. Since they didn't do that for this one, what we have to do is we have to multiply the top by a number and the bottom by a different number, so that way it forces two of the variables to be opposites of each other. What do I mean by that? Well, let's eliminate the x's. To eliminate the x's, let's multiply this one by 3, and that'll give us a positive 6x. Let's multiply this one by negative 2, so we get a negative 6x. And remember, you have to distribute this to all three terms. So let's rewrite this. 3 times 2x is 6x, plus 3 times 7y is 21y, equals 3 times 4 is 12. Now come down here. Negative 2 times 3x is negative 6x. Negative 2 times plus 5y is negative 10y, equals positive 10, because negative 2 times negative 5 is positive 10. Now if we add this, these cancel. This here gives us 11y, and this here gives us 22. And now we can divide off the 11 to get y equals 2. All right? Now, these two are equivalent systems because this one would reduce back down to this one. If we factored out the 3, we'd be back to here. If we factored out the negative 2, we'd be back to here. So these are equivalent systems because 2 will solve, y equals 2 will solve this, y equals 2 will solve this as well. So this is elimination using equivalent systems. Now that we have y, we do it just like we always did. You stick it back up into here into the easier equation. Let's do 3x plus 5 times 2 equals negative 5. So 3x plus 10 equals negative 5, minus 10, minus 10. 3x equals negative 15. Oops, supposed to divide by 3. X equals negative 5. Okay, so our solution to both of these, because remember they're equivalent systems, is negative 5, 2. Okay, negative 5, 2. So as you can see, solving by elimination, which is what we did on the previous paper, and solving by elimination using equivalent systems is pretty much the same, except when you do equivalent systems, you have to multiply the top equation by a number and the bottom equation by a different number to force two of the variables to have opposite coefficients. So here we have a plus 6x, here we have a minus 6x. So when we add, the 6x and the negative 6x cancel, leaving us with only y's. But after that, it solves the same. You find one, go back to your originals, plug that variable in, and solve for the other one. All right? So that's it for this video. You can watch this as many times as you need to. Make sure you understand the concepts and come tomorrow ready to work some problems. See you tomorrow.